Hey guys, Mr. Jenkins here. Here with your first lesson for Chapter 5. It's about rate of change and slope. Those are basically synonyms of each other. And as you can see, those are two vocabulary terms. Rate of change, slope, same thing. Our learning target or targets are to find the rate of change from tables and find slope. I think this book refers to slope if it's from a graph. Rate of change if it's from a table, but really it's just two different terms that mean the same thing. A says finding rate of change using a table. So the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So is it constant? That is also known as, if we put these on a graph, would it be linear? Is it linear? Okay, that's the real question. All right, so we have to understand how these tables work. If it's a vertical table, the left-hand column is my input column, the right-hand column is my output column, right? So distance is a function of time. Anyways, what we want to do here is find basically how do we change to get from 260 to 520. And obviously that's going to be a little bit tough to know, but just do 520 minus 260. That's 260. So we did plus 260. 520 also plus 260 is 780. And then what do we do to get from 780 to 1040? We do plus 260. So looking like we definitely have a pattern over here. Do we have a pattern over there? Yes, obviously we're just counting by ones. So I'm going to skip all that and say every time we did plus 1, right? So M, which you'll hear me refer to M a lot, that's just going to be slope or rate of change, is going to be 260 over 1. It's constant the whole way through. So the answer would be yes. So yes. And so we answered the first part of the question. What does the rate of change represent? So for this, you just kind of think about your labels. It represents 260 Y, so 260 feet per 1 X, so per 1 minute, all right? So it represents that the rate of change is 260 feet per minute. That's all. That's your rate. That's the rate at which the band is moving. Okay. Let me skip B and leave that one for you to check. I want to look at C because it is in a horizontal table, right? These tend to give kids more trouble for whatever reason. In a horizontal table, the top row is your input row. The bottom row is your output row. So in this, elevation is a function of time. And this is showing the descent of an airplane. So maybe coming in for a landing. All right, so first of all, is it linear? Is the rate of change constant? So let's see. So if I did 29,000 minus 30,000, 29 minus 30 is -1. So that'd be -1,000. That'd be over 2 minutes, okay? 27.5 minus 29, that's going to be minus 1,500 over plus 3. And then the last one, sorry, I'm going to get kind of jumbled here. This minus this, 24 minus 27.5 is going to give me -2,500 over plus 7. Okay. So is it constant? First of all, it's definitely not as obvious as our last example. So we would probably want to do some division there to check. But if I do -1,000 divided by 2, I get -500. If I do -1,500 divided by 3, I get -500. So those two are equal. And then if I do -20, sorry, is that right? That's -3,500. So that wouldn't have worked out, but I did the math wrong. Sorry. This last one should have been -3,500. Maybe you caught my mistake there. Anyways, -3,500 over 7 is also negative 500. Okay, so the answer here is also yes. And then what does the rate represent? It represents negative 500 feet per minute. All right, so the rate is minus 500 feet per every 1 minute. That's just a unit rate. That's all that is. Okay, that's what a slope is. All right, so finding slope from a graph. These pictures aren't real pretty, so we'll do our best with them. All right, so what you want to find here are what I like to call, we want to use corner points. All right, so right here looks like a corner point, and that would be 5, 0. And then looks like this might be a corner point, which is 1, 1. And then when it's unclear, which it kind of is off of this, I see if does it follow the same pattern. So that would be down 1, 2, 3, 4, right 1. So let's try that again. Down 1, 2, 3, 4, right 1. It looks to follow that same pattern. So it also goes through 2, negative 3. I'm just being thorough in my checking there. Okay, so I think it's always smart to look from left to right. So let's look at what's the slope from here to there. And again, I'm going from here to there, right? So my rise from this point to this point would be down. So that'd be negative 1, 2, 3, 4 units. So that's a minus 4. And then my run is going to be right 1, so over plus 1. Okay, the negative thing is what gets people on slope. People understand rise over run and all that good stuff, but the negative positive thing is the thing that'll get you. Okay, so negative 4 over positive 1, and we would just simplify that to negative 4. That's the slope of that line. Okay, if you want to leave it as negative 4 over 1. Math Excel might take that, but as far as writing it into an equation, I suggest simplifying to negative 4. Okay, so just big picture, you know, I mentioned the positive negative thing. I suggest just looking at it right off the bat and saying, you know, is this a positive slope line or is this a negative slope line? So as I move from left to right, I went from here down to here, so I decreased. Decreasing function is going to have a negative slope, okay, if that helps. All right, so the next one, I'll do one more of these. Just find a couple points. Looks like it goes through 0, comma, I guess we're counting by 1, so we'll call that negative 3. And then looks like it goes through 2, negative 2. I want to just make sure though, if I go, if I can go from here to here, down into the down 1 to the left 2. Let's just make sure down 1, left 2. So it looks good there too. Okay. So my slope then, going from here to here, is going to be rise 1. Rise goes on top. Rise 1 over run positive 2. 1 over 2 just simplifies to 1 over 2. All right, and another question I get sometimes: how do you know which 2 to use? The answer is it doesn't matter. Say I go from here to here. That'd be rise 2, run 4. So 2 over 4 would be also 1/2, right? So they will all kind of reduce to the same thing. C and D, I'm going to leave for you. And so the next thing that, you know, I guess the hardest thing probably that most of you will have is example 3. So let's go ahead and look at those. What if I just give you 2 points and no graph? How do I find it algebraically? Okay, so the answer is you use the slope formula. All right, so that is, and this is important, might want to write this down. It's y2 minus y1 over x2 minus x1. And really, you can flip those around. You could say y1 minus y2 over x1 minus x2. The important thing is that it's the difference in your two y's over the difference in your two x's. All right, so I'll show this just the old school way, and I'll show you another way to kind of organize it to where you might want to use that way. All right, so if we're just talking about our points, I'm going to go ahead and label them. All right, so my first ones I'm going to call my ones. So this first -1 is my x1, then the 0 is my y1. So 3 would be my x2, and -2 would be my y2. All right, so subbing in to my formula I just showed you, y2 minus y1. So that's going to be -2 minus 0 over x2 minus x1. So 3 minus -1. So that's going to give me -2 over 3 minus -1, like 3 plus 1. So -2 over +4. So negative over positive is negative overall. And 2 over 4 simplifies to 1/2. So -1/2 is the slope of that line. Okay. Now, I don't really like thinking about this in terms of labeling them and things. I just remember if I subtract -2 minus 0, then I have to go the same way with my x's. It's got to be 3 minus -1. Okay. So some people like to think about it that way. I think a lot of people, especially visual people, kind of like this trick. All right. So this is just another way to show your work to find slope. This is what I call stack them and subtract them. Obviously, you're not going to find that in any math books, okay? But we are doing the same thing, all right? So when you stack them, it doesn't matter if you do this one over top of that one or vice versa. Since, you know, I'll just do this one over that one, but you could flip the order there. Okay, so I stack them, and I'm going to do 4, -1 over 1, 3. So this way my y's are lined up and my x's are lined up. What you have to be careful of is if you do this, you have to remember that this is my rise over here, and then this is my run over here. Okay, so you just got to be careful, and that you are doing minus. It's stack them and subtract them. A lot of people would put 2 here and 5 there. That's incorrect. You add it. Okay. So -1 minus 3 is going to be a rise of -4. 4 minus 1 is going to be a run of +3. Okay. And then I just put it together. So my slope then is -4 over +3. And you can really leave it that way, but sometimes you'll see that as just -4 over 3. Okay, just changing where the minus sign is. And it could even be written as +4 over -3. Just pay attention to the number of negatives. All right, so that would be kind of stack them and subtract them. I don't know if you like that better. I would just say pick one of these methods and stick to it, okay? I'm going to leave C and D for you guys to try. And again, feel free to ask about these when we're working on homework too. Mr. Jenkins, I tried C. I looked at your notes. Still didn't make sense. Can you talk about it? And then I'll ask you, are you using the slope formula? Or are you using stack them and subtract them? And I'll show it your way. I'm like Burger King over here. Have it your way. All right, so last thing is these special cases, horizontal and vertical lines. All right, so knowing which is nice for vocabulary purposes. I know this is hard to see. I'll trace it. This is our line right here. So straight across is called horizontal. That's a horizontal line. Let's think about its slope. Okay, you can pick any 2 points. Let's just pick, say, this one, and I don't know this one, right? So if I do my rise from here to here, how many did I rise? I didn't go up or down any, so I rose 0. I can run 2, but really, if 0 is your numerator, it's irrelevant what your denominator is. 0 out of anything is equal to 0. Okay. All right, and this is going to be true for all horizontal lines. True for any horizontal line. Slope is always 0. All right, so is that true for a vertical line? Okay, so straight up and down line, also known as a vertical line. Okay, let's look, right? So if we look from here to, say, here, my rise, say, from this guy to this guy would be 2. My run would be no side-to-side change, so over 0, right? If 0 is in your denominator, okay, if you might want to try typing that in. What's 2 divided by 0? And your calculator will say error there. That's a good reminder that you can't divide by 0. So we say this is called undefined. So we would say M is undefined. Another vocabulary term that you need to remember. Undefined. All right, and guess what? That's true for any vertical line. All right, any vertical line is always going to have an undefined slope. Easy to mix these two up, right? So we'll practice it. You'll make mistakes and hopefully eventually remember. Okay, so it's not as obvious if we're just given 2 points. But one thing that kind of sticks out to me looking at C and D, just big picture, I see that one X is 4 and the other X is 4. That could be a red flag. Same thing on D. The Y's are both -3. That could be a red flag. Okay, so let's finish up with these and see what happens. So I'll do this one, slope formula. So 2 minus -3 over 4 minus 4 is going to give me 5 over 0, right? So here you got to pay attention to where is the 0. So I know if 0 is involved, it's either going to be 0 or undefined. If I'm not sure, I can always type it in. But this is more like that one over there. This would be a vertical line. So here we would say that slope is undefined. All right, and then the last one, you could probably guess what's going to happen, but I do want to show you one more, stack them and subtract them. So I'll stack this one over top of that one just to show you that it doesn't matter. Because last time I stacked the second one over the first one. So -3 over top of 5 comma -3. So my rise is going to be -3 minus -3. That's 0. My run, -1 minus 5 is -6. It doesn't really matter. It just matters which goes on top of the other. Rise goes over run, so M is 0 over, doesn't matter, 0 over anything equals 0. You always want to simplify. Don't leave it as 0 over -6. Okay, your homework assignment, your practice assignment is, as per usual, Math Excel. So this will be an important start to the chapter. You're not going to have success in this chapter if you can't find slope, either from a graph or from 2 points. So it's important. Hopefully it seems simple because you did this a lot in pre-algebra. But we know the way math is, you forget things. So that's why we review before we move on to more difficult topics. Thanks. And as always, hopefully this is helpful. Have a nice day. Bye.